Good day, viewers at home. In case you're hearing my voice for the first time, my name is Engineer Will.I.am plus S. In our today's physics class, we shall be discussing motion, but our major focus will be on rectilinear motion. So the first thing I need to explain is the terms used in describing motion. What are the terms used in describing rectilinear motion? One of the terms used in describing rectilinear motion is distance. Distance. What is distance? Distance is simply the space between 2 points. So, and we can represent distance with capital letter S or this. So in physics, we use this to represent distance, S or this. Then the next term is displacement. Displacement. Displacement is also represented with S. We have time. Time is represented with T. You already know the unit, which I've discussed in my previous video. Then we have speed. Speed is represented with V or U, V for speed. We have velocity. Velocity is also represented with V or U. And we have acceleration. Acceleration is represented with A. So these are the major terms used while describing rectilinear motion. S for distance or displacement, T for time, V for velocity or speed, and A for acceleration. We also have retardation. Retardation is just the opposite of acceleration, which is decrease in velocity, and is also represented with A. So these are the terms used in describing rectilinear motion. So if we in today's video, our major focus will be on calculation of rectilinear motion. So if you want to solve question on rectilinear motion, you should be familiar with the equations of uniformly accelerated motion, which include 1 v equal to u plus minus at. So this is called the first equation of motion. We have another one, s equal to ut plus minus 1 over 2 at squared. We have v square equal to u square plus minus 2as, and we have s equal to u plus minus v divided by 2 times t. So these are equations of motion. This involve acceleration, this also involve acceleration, this involve acceleration, but this does not involve acceleration because there's no a here. So these three are majorly for acceleration. So how do you use this equation? Whenever object is increasing its speed or velocity, use plus. But if the velocity of object is decreasing, use minus. So if an object is increasing its speed, you can say v equal to u plus at. That's for acceleration. But if it is retardation, change the plus to minus and solve your equation. Just as simple as that. The next equation we are going to look at is the one for motion under gravity. Motion under gravity. So when we say motion under gravity, we simply mean motion of free fall. So whenever object is falling down, we call it motion under gravity. Our equations can also be used here, but we are going to change few things. Here that we have a, which is acceleration, will now be changed to acceleration due to gravity, which is g. Here, which is distance, will now be changed to height, which is also distance. So this equation will become v equal to u plus minus gt. The second becomes h equal to ut plus minus 1 over 2 gt squared. The other one becomes v square equal to u square plus minus 2gh. So these are the equations for motion under gravity. We use plus if the object is falling down, which is the object is accelerating. Then we use minus if the object is thrown upward, that is retardating. So that is how these equations are being used. The next you need to know is one. Whenever an object moves from rest, initial velocity is 0. So the question will just say an object moves from rest. Nobody will tell you that, but you should know that u in such case is equal to 0, which is initial velocity. So u represents initial velocity. Then 2, whenever object is brought to rest, v is equal to 0. V in physics represents final velocity, u initial, the velocity you start with. Then 3, whenever an object drops from a height, if you have a palm tree and the palm fruit drops from the palm tree, the initial velocity of that palm fruit, which is u, must also be 0. And 4, whenever an object is thrown vertically upward, final velocity, or the velocity at the highest point, is also equal to 0, which means final velocity is equal to 0. So if you throw object up, the velocity at the highest point is 0, which is v equal to 0. These are the things you need to know when solving question under rectilinear motion and also motion under gravity. We're going to look at a few examples on motion under gravity for today's class. Let's look at question 1. A motor vehicle is brought to rest from a speed of 15 meters per second in 20 seconds. Calculate the retardation. Solution. What do? The first thing you do is to list out the quantities involved. A vehicle is brought to rest. Since the object is brought to rest, it simply means that final velocity is 0. I've explained that already. It's brought to rest from a speed of, so the initial velocity now is gone 15 meters per second. That is it. In the time is 20 seconds. In 20 seconds. So time is 20 seconds. We are now asked to calculate the retardation, which is A. So what do? We have our equation of motion like V equal to U plus minus AT. We also have equation like V square equal to U square plus minus 2AS. And what do? Look for the equations that have all this data in it. I think the first equation has this. But since the object is retardating, we change this plus to minus. We're having V equal to U minus 80. So what is my V? My V is 0. What is U? U is 15. Minus, what is my A? Acceleration is unknown, and the time there is 20. So which will now be equal to 0 equal to 15 minus 20A. So if I collect like terms, I have minus 15 equal to minus 20A. This will cancel this. So I have 15 equal to 20A. Divide both sides by 20. This will cancel this. I have A equal to 15 all over 20. If I divide 15 by 20, I will have 0.75. A equal to 0.75 meter per second square. So that is the retardation of the vehicle. Excuse me. Believe that is clear. Then the second question we have here says the velocity v of a particle in time t is given by the equation v equal to 10 plus 2t raised to power 2. Find the instantaneous acceleration after 5 seconds. After 5 seconds. How do we solve such question? Solution. Very simple. So what do we do here? Whenever you have questions like this, we have v equal to 10 plus 2t raised to power 2. and we are asked to look for acceleration. What we do here is to use differential calculus. We differentiate v with respect to t to get the acceleration. So velocity over time will give us acceleration. So how do I do this? dv over dt is equal to, if I differentiate a constant, what is a constant? A constant is a number, or a number without a variable is known as a constant. So if I differentiate this constant, I have 0 plus, if I differentiate this, how do I do it? This will come to multiply the 2, which will give me 2 times 2 t raised to power 2 minus 1, using the rules for differentiation. So which will be equal to 0 plus this already, so this times this will give you 4t. 2 minus 1 is 1, so I have 4 times t. So but they say the acceleration after 5 seconds, so which means I'm going to substitute my t for 5, which will be 4 times 5, which will be equal to 20 meter per second square. That is how you solve this kind of question.